Hello guys, it's Easy Maths, and today we're going to be looking at a whole new topic, sequences. In this video, arithmetic sequences, and we're going to do two things. First of all, we're going to find the nth term using the terms in the sequence, and then secondly, we're going to solve for or extrapolate different terms. If you don't know what extrapolate means, I'll let you know when we get there. Okay. So we see a sequence, and we have to, first of all, identify what type of sequence it is. So for arithmetic sequences, the key is that the difference in between the terms is constant, is the same. So what I really do want you to do, especially for when things get harder in other types of sequences, is to draw these mountain type shape arrows upside down, and then see what the difference is. In this case, it's 4 in between all terms, meaning that this sequence is officially arithmetic. Okay, let's have a look at a different example. So let's go back to our black. Let's draw our arrows. It may look like a more childish thing. No, trust me, older students also do it. Let's say 3, 2, 5, and 4. Well, from what I can see here, this is simply not an arithmetic sequence, just because the difference is not constant. It doesn't mean that it doesn't have an nth term or that it can't be. No. It's just not an arithmetic sequence if the difference isn't constant. Okay. Now, the key thing here is plus or minus. In this type of sequence, that's the only thing that matters, if we can say it that way. It's plus or minus, plus 4 or also minus 4. If the sequence were to be 17, 13, 9, the opposite, that's also completely valid. Okay, now let's go through actually, now that we've identified it, see how we can find an nth term. So I have a few things to cover. So n is the term number. And what I mean by the term number is a sequence is composed of terms. The first term, the second term, that is n. So n equals 1 is 3, n equals 2 is 8, in this case obviously, and so on. Okay, so we know what n is. Next up, I want to introduce you to, let's grab a different color, orange for example, D. D is the common difference. I'm going to put constant because common, I think the word constant makes it clear what it actually is. But yeah, it's known as the common difference. And that is the difference that you find in between the terms. So in the first example that we looked at, D equals 4 because it was 4. All the values were 4. In this one, for example, let's have a look. Let's draw our mountain type shapes. Let's see. So from 3 to 8, we have 5. From 13 to 8, we have another 5. 18 to 23. Okay. This is looking like quite a lot of 5s. But it also is important to know that it can be minus. In this video, I'm using examples that are positive, just because, not really a reason why. But these values can also be minus 5. So yeah, take that into consideration. Okay, so with all values being 5, we have officially identified that it is an arithmetic sequence. So let's see. I'm gonna give you 2 methods to how to that English was not to solve this type of sequence. First of all, this is the more simple, basic method. Write dn, always dn, the value of d, the difference in between the terms, n, 5n. Okay? Are we done there? No, we are not done there. I want you to substitute 1 for n. So 5 times 1, that is 5. Okay, but our first term is equal to 3, right? And 5 is not equal to 3, obviously. And they should match. So then we simply add -2. Whatever we need to change, plus, minus, for it to equal to the term that we're substituting in. And we'll check later that this rule works for every term in the sequence. The second, more advanced method is the actual formula, un, which is the general term, the nth term, equals to u1, this is the first term, as in 1, plus n minus 1d outside the brackets. This may look more complex, but when it does get harder, it's a simple formula that you can always use quickly, and it's more mathematical, let's just say that. But at the end of the day, it's the same, gets you the same rule. So we substitute in all the values that we have, so 3 plus n minus 1 times d, which is 5 in our case, would be 5n minus 5, and that would equal to 5n, then 3 minus 5 is -2, 5n minus 2. Different methods, same answers. So yeah, both are valid. One's maybe a bit more mathematical, but yeah, 5n minus 2 would be your nth term or general rule. Both are correct, fine. Okay, so we've seen how you can actually figure out your nth term. Now, how do we actually apply it? Okay, let's see, part 2. Solve for or extrapolate different terms. Extrapolate basically means find the value of terms that aren't in the sequence. I'll get to that now. Okay. Solve for, let's see, with 5n minus 2, which is our general rule. We're gonna substitute in, let's see, we're gonna find the value of, we can do, let's see, we can, the 5. Guys, sorry, I took a long time there. Just wanted to pick one that wasn't too easy, but that actually showed what I was trying to tell you. So we substitute in 5 for n, so 5 times 5 minus 2. This would be 25 minus 2, giving us 23. And this will always work. There's no if there's an if or it's a different value, that unfortunately means that the nth term is wrong or that you substituted the value in incorrectly. So 23 is the final answer for our fifth term, as we know. Extrapolating now is saying, okay, I'm not gonna add 5 until I reach a certain number. With the general rule, you can find the 100th term, for example, any number. All you do is substitute in 100 in this case for n. So 5 times 100, close brackets, minus 2. That's 500 minus 2, as we can see, 498. And this is the value. You shouldn't check because you would need to add 5 a lot of times, but this is the value. So this is all I have for you today. You've successfully learned arithmetic sequences, but I really want to highlight the plus or minus. That what makes it unique in a way from the other types. So yeah, I hope you enjoyed. Let's tick that off because we did it amazingly. Share, comment, subscribe, and see you in the next video.